Okay, so today we are learning transformation of quadratic. Okay, in order for us to do that, first thing first, we have to know what is a quadratic parent functions and how does that look like. Now, to be a quadratic, you gotta know your specialty. Your specialty is that you need to have a power 2 and you gotta have a U shape. It gotta look like a U. Okay, so we have y equal x squared is a parent function of quadratic. And if you look at the shape, we got a U shape. And to see they also start from the origin because our parent function always start from the 0, 0. So this is our parent function. Our goal today to understand what kinds of transformation go into chain and how does that affect the parent function here. So we have a f of x minus h plus k. When we look at f of x, we know this is the function of y. What is our original function? Because f of x is just y. We want to see what kinds of transformation affect to a, h, and k. Okay, let's go. So we're going to explore every single one feature. So first thing first, I would like to start with this one right here. They have three graphs already ready for you. If I close it, you see this is parent function x squared. We want to know how does it change right here when I have the new function 2x squared. The colors is blue. We want to see how it changed. So as you can see, for the first one, my parent function a equal 1, being the number in front of x squared. The number in front of the blue one right now is 2. So how is 2 compared to 1? Big number or small number? 2 is bigger. What happened and how did the graph look? The bigger the number, the narrower the graph look. So let's take a quick look with one more to see we are sure. So the next one right here, as we can see, our a this time equal 5. And the number getting even smaller. So we call them vertical stretch. So imagine you are stretching yourself right now. You pull in the graph are getting more and more taller, more and more further away. So from the x-axis. So we pulling away, we're stretching, and we're getting narrower. So in summary, if we have a big number, always compare with 1, okay? This is our parent function. Whether you like or you don't like your parent, we only have one parent, and I hope you love your parent. I do love my parents so much. So here we go. If I have big number compared to a, compared to 1, my bad, then the function going to get narrower, the graph gonna get narrower, and the word you're going to call for that is vertical stretch. Take a rubber band and pull it up. You can see the rubber band getting small, narrower and narrower, and we call them vertical stretch because it's stretching up. So imagine if I have a fork pulling this one up right here. So we call them vertical stretch. Okay. So we're gonna have that one right there. So we're gonna moving on to the next one to understand what is the change. Okay. I think that I should write all the formula down so to make sure we have everything we have so far. So far we learned about A because as you can see, this is the number in front of the equation, right? So here go all of this and right here is again our parent function A equal 1. So let me rewrite them right here and I will not erase it just so we can have everything in the same corner. In the same spot. So the c f of x is just a function, but the only thing we focus on is A. Right now, we already see if we have a big number, the one which is did, big number compared to 1. Okay, we always compare to 1. Big number compared to 1, and then the graph going to get narrower, and then the words going to be vertical stretch. Okay, big number, you're stretching big. So what happened right now? I want to take a quick look. So right now, my A equal how much? How much is my A equal this time? My A equal 1. This A right here equal 1/2, and this A equal 1/5. What happened to the number? The number getting smaller, right? So what happened if the number getting smaller like that? Let's see. So right here, how does the graph look like? The graph get wider. and even wider, so more and more. So imagine right here at the graph getting really, really big. Think about like originally, this is right here, right? We push down to the x-axis, we come closer to the x-axis. So we push even down, even more and more. So right here, the smaller the number getting smaller, right? But the graph are squid, I've pushed all the way down more and more. The graph get wider first, right? The graph get wider. Look, it wide. This is the original, right? The parent, here we go. And then it get wider, and then it get even wider and wider and wider. So it push everything down. So right here, we're gonna call them vertical compress. Okay, just like that. Because you push everything down, you press it down, you press it down. So down, down, down. Okay, so that's your vertical compress. So far we learned in two with A. We're gonna go on to the next one, and I want to see how did the transformation happen. So in here we talk about the size getting smaller, getting bigger, getting narrower and wider. So the next one we are about to do is this one right here, in which that we talk about translates up and down. Again, the green one is the parent function. When x squared plus 3, knowing that I'm plotting 3 to the entire function, where do we go? What happened to the graph? I'm adding 3 to the whole equation. I'm adding to the y-axis because this is the whole function represent y. So I'm gonna go 1, 2, 3 up, okay? How about if I plus 5? Look at the new function. We always look at the, we always compare to the parent function, that's gonna be the green one. So 1, 1, 2, 3, 4, 5. So the graph going up, how many units? You go up, how many units? It's going up 5 units, as you can see, okay? What happened if I subtract? What happened if I subtract? So let's try the next one. Let's see how it goes. So I'm gonna close off this, but I'm just gonna open this one. So what happened to the graph? It shifted down, right? So the thing that's gonna affect this one with up and down is when it affects directly to the y-axis. So it's going to be k. So for that this difference right here, if we add to k, we're gonna go up. And we subtract to k, we're gonna go down. Just like that, okay? So that is our translation up and down. What about the next letter that we're going to talk about? Get what? That's going to be H. So take a quick look right here. H is a letter that directly go with X. Remember the keywords H, they go directly with X. And I'll take a quick look right here. If it affecting X and the way the X-axis go is left and right. So without any surprise, take a quick look, get where we're gonna go. Now in this one right here, it actually going to the right. Even though normally we think about, oh, if I'm subtract, I'm supposed to go to the left. I'm adding, I'm supposed to go to the right. This is a little bit of opposite. The reason is, if you look at the equation formula, is have a -8. So it's kind of, you have to think of opposite this time. So in here, when you subtract, you actually gonna go to the right. So you doesn't go to the left, okay? Keep that in mind. One more time, as you can see, compared to the parent function, I have a -3, it affecting the x, and it goes to the right. So get what? If I have +3, so get where I'm gonna go. So I'll do the same thing. My red function will go to the left. How many times I add, it go exactly the same thing. So 1, 2, and 3. So I'm gonna go to the left when I'm at. Okay, knowing the transformation, especially the rule, will help you where they go, and it's easier because it's exactly the same for all functions. Finally, we also have this one right here. So let's take a quick look again. I'm having my first function. Right now, we're not using the parent function, but it's okay. So let's take a look at the A. My A right now is 2. And my A, the number in front, correct? A is equal -2. As you see, the number are the same. The only difference is our sign. This is positive. When you're positive, what happened? Are you happy or you sad? You're happy, right? So the graph going to open up. It's a happy face. Boom, boom, boom. Here we're going to draw it out. Happy face. Here we go. But right now we got a negative. It's a sad face. So what happened to the graph? It go down. Okay. So let's see if it go down or not. Let's check it out. So the graph actually does go down. So as you can see, what kinds of transformation happen here? So this is going to be the last one. And imagine like here, the graph are flipped over the x-axis. So we call this one is reflection. So this is going to be the last node, but it still affect the letter A because it's right in front. So when I see a negative, the graph going to reflect or flip over what kinds of axes, the axis that they are flipped in between right here. So that's gonna be your x-axis, okay? So this gonna be reflect or flip over x-axis. Okay, I really hope that makes sense to you. So those are the transformation rule that we go into you. Highly recommend you to write it down and keep it because you're going to use it over and over many times. Finally, let's give a quick try, see if we can put everything together or not. Okay, this is pretty much the same, so I'm just gonna move it on. Here we go. So let's see. Okay, so now we have this question that said, without graphing it, can you describe how this function is transformed? Okay, so in order to do that, I like to write the formula down. I always like to write it down just so I remember how to do it. Okay, so here we go. Now I'm going to take a quick look. As you can see, if you see f of x, don't worry, this is just a function. So that means we are talking about quadratic. Okay, so let's take a quick look. I always try to label a as the number in front, h is the one in the middle, and k is the one in the back. So the one in the middle always in parentheses. So in this case right here, do you see any parentheses? No, right? So that means we are not talking about 8. We only talk about A and K. So you look at K, this is minus K. So where do we go? Down 1. That's it. Okay. Right here, if I'm looking at A, being the number in front, this is 2. We always compare to 1, to a big number, small number compared to 1, big number, right? If this is big number, then it's going to be vertical stretch. You're stretching big by 2. So this question right here, we did not see the new function, but we have to follow the instruction to make a new one. They said, write the equation that will shift the parent function 2 units to the left. Oh, when I go to the left, I know this is my letter H. 5 units up. Okay, so I know that's in my letter K. And stretch the parabola by a factor of 3 stretch. So I know this is A. And reflect, so that I know this is another letter A. I like to put a negative every single time I see the word reflect because I know that's in my, what is that called? Reflection. So now I'm going to rewrite this. This is A, right? They said reflect, so I just put it underneath. Let me try it over here. A, here we go. So I have A f of x minus 8 plus k. Now I'm going to rewrite them. So I have negative and then stretch by a factor of 3. This is A, so I put it in the front, you see, in the front. And then I have go left unit. So here we go. I'm going to have x. Go to the left. So I'm going to put, when you go to the left, you actually plus. So I'm going to put plus 2. And then I go up 5 units. So I'm going to put plus k. But in this case, it's 5. Now this question right here, guy, I would like to tell you, I'm not writing the f anymore, but instead of f, I'm gonna put a power 2. Why? Because f is a generic notation for function, all functions in the world. Right now, we're clearly talking about quadratic with a parabola. So we don't need to put the f anymore, but we have to put the specialty of the function. So I'm gonna write the power 2 on top, and I don't have to put the f. the power 2 will represent what I'm talking about. I want to make sure what I did here correctly, so I'm just going to grab them. So negative 3x plus 2. And then I know that my picture looks kind of messy, but here we are. We got square, and then we got plus 5. Okay, so take a quick look. Let's observe what we have to see if it's correct or not. Let me erase some of this. So first thing first, they said we're gonna shift the parent 2 unit to the left. So let's check it out. Did I go 2 unit to the left? I start from here, so I go to the left, 1, 2, okay? I stop right there, right? And then I stretch the parabola by a factor of 3. Now, when you stretch, you're getting skinnier, narrower, right? So my graph, the black one, they'll look narrower. That means you're stretching. And then I also reflect. So I reflect, so as you can see right here, this graph open up, the green one, and the black ones is open down. So it does have the reflection. 5 units up, so 1, 2, 3, 4, 5. So I have all of that, okay? You don't have to grab all the time, but if you want to double check your work, I highly recommend you do that, okay? So here we go. And that's it. So it's telling me what I just did correctly, okay? I really hope this one makes sense to you guys at all time. Please definitely ask. If you don't ask, the answer always no, you don't get it. So please ask me or watch this video 10 more thousand times and hopefully it will make sense to you. Take care.